through the process of hypothesis testing, and we know we're going to make either a reject or a fail to reject the null hypothesis conclusion. Now it's time to address what can happen, namely that we can be wrong and make a mistake. So let's look at some of those errors. We're going to look at statistical significance again and rejecting or failing to reject a null hypothesis, making those mistakes, the types of errors that you can make, a type 1 or a type 2, and the sources of error, such as sample size, alpha level, and power. So, when we reject the null hypothesis, we are saying that the probability of seeing this result, this particular sample mean, if the null were true, is low enough, like less than 5% chance, that we can reject the idea that we live in the null world. We can conclude there is a statistically significant result, but there is still a chance that the null might be true. It may be a very small chance, but it's still a legitimate chance. When we reject the null, but the null is actually true, we've just made a mistake. We've committed an error. Types of errors: type 1, type 2. Even with our powerful statistical tools, and even with a really small probability of less than 0.01, we can still be wrong. We can still be that 1 in 100 that misses the truth. So there are two main types of errors you can make when it comes to hypothesis testing. There's a type 1, which is a false positive, and a type 2, which is a false negative. This is called a truth table. Up here we have reality or the truth, the actual state of affairs. And over here we have the results of a hypothesis test that you run. So we have 4 different situations that could happen here. 2 places you could be wrong and 2 places you could be correct. Let's look at the 2 correct ones first. So if in reality a particular drug, let's say, has an effect and does work, and your test rejected the null hypothesis, meaning that you found an effect, then you have correctly rejected the null hypothesis, and it's a true positive. Yay! Now, if that drug has no effect in reality, so right here, and your test also finds that it has no effect, so you fail to reject the null hypothesis, you also have a true negative, which is also correct. Yay! But now let's look at the 2 ways that you can be wrong. Let's say that that drug has no effect in real life. It's just as good as a placebo. So in reality, it has no effect, but you ran a test and you rejected the null hypothesis incorrectly. You have now just committed a type 1 error, and that is called a false positive. You said there was something there when in reality there's not. Now, a false negative, let's say that in reality that drug does work, but for whatever reason your test did not find an effect, so you failed to reject the null hypothesis, then you have a false negative. You said that nothing was there and it had no effect, but in reality it does, and that's a type 2 error. So let's look at this type 1 error again, this false positive. Remember, you might reject your null hypothesis and be very excited, but there is that possibility that you could be that fluke, that 1 in 20 that actually missed the mark. And if that's the case, this would be an example, again, of a type 1 error, a false positive. You said there was something there because you rejected your null hypothesis, when in reality, you were just missing the mark and there's really nothing going on there. Mistakes were made. Let's test. I'm an excited researcher, anxious to release my new drug. I do some tests and conclude that it does indeed work better than a placebo, but in reality, the drug has no effect. What type of error have I just committed? In this case, I have just committed a type 1 error. Remember, in reality, the null is true, meaning there is no effect. But I said the null was rejected. So I said there was something there when in reality there was not. Let's try this one. I'm an excited but financially poor researcher and can only afford a small sample size. I do some tests and conclude that my new breakthrough therapy doesn't actually work. But in reality, the treatment does have an effect. What kind of error have I just committed? Now in this example, the null hypothesis in reality is false, meaning that we should reject it. But for whatever reason, my statistical analysis failed to reject that null hypothesis. So I've committed a type 2 error, and in this case, I'm saying there's nothing there, when in reality there actually is. So the type 1 errors, those false positives, are typically the types of errors we work hard to avoid committing. We'll see this when we look at ANOVA and family-wise, also called experiment-wise alpha, in a few lessons. The probability of a type 1 error is equal to our alpha. That's why it's been in some of those truth tables. So if we choose a lenient cutoff, let's say that we're using the 0.10 instead of 0.05 or 0.01 as our alpha level, we have a higher chance of committing a type 1 error, a 1 in 10. So type 2 errors, or these false negatives, in social science research can occur when there is a limited sample size or your alpha level is really strict. In medical testing, type 1 errors can have heavy consequences. One particularly dangerous example of a type 2 error is when someone takes a medical test, for example, a cancer screening or maybe a COVID test, and is told the test is negative, when in fact they do have the disease. These types of errors can occur because medical tests are not 100% accurate at detecting true positives and true negatives. So what's the gist of it again? Type 1 errors is you saying there is something there when in reality there's not. And type 2 errors is saying there is nothing there when in reality there is. I particularly like this tangible example. So a type 1 error would be like a doctor telling a man, "You're pregnant." No, that is a false positive on that one. In reality, you are not pregnant, but the test said you were. Now, conversely, the type 2 error would be a very, very pregnant woman and a doctor saying, "You're not pregnant." That is very much a false negative. You are indeed pregnant, but the doctor said you were not. So hopefully that'll help you remember type 1 and type 2 errors. So what are some of the sources of this error? Well, we know a type 1 error is related to alpha. So if you pick a very lenient cutoff for your alpha, you have a higher likelihood of committing a type 1 error. Type 2 errors occur when we fail to find a significant effect when in reality there is one. And this is related to something called power. And power is the ability or the probability of correctly rejecting a null hypothesis when in fact it is false. So basically the ability to detect an effect. This is much more complex than just this one sentence here, but that's another lesson. Also, the probability of a type 2 error occurring is high when your n is small. Your sample size is really, really small. Maybe there's a lot of variability and just not enough power. And if your alpha is very small, meaning that your alpha level is really, really strict. All right, we've made our way through. We now know all the steps of hypothesis testing, and we are aware of the types of errors we can commit. Now it's time to start running some statistical tests, and we're going to start with t-tests. I will see you